Hi, Chintanji. We will start the session within 1 or 2 minutes, okay?
Sure, no problem. I'm audible properly, right?
Yeah.
Okay, thanks. No problem.
So let's start the session. Good afternoon, everyone present in today's session. On behalf of Smart India Hackathon team, I welcome Shri Chintan Adhiyaji from TCS and all the candidates to today's online training session. I am Ashish Sharma, your host for today's session. This session has been especially organized to help you understand the today's topic, that is backend development and microservices, which will support you in preparing better for SIH 2025. We are honored to have with our expert trainer who is an industry professional with extensive experience in this domain. Thank you, sir, for joining and providing training to our candidates. Now, without further delay, I would like to invite our respected trainer, Shri Chintan Adhiya ji, to begin the session. Chintan ji, over to you now.
Thank you, Ashish. So, good afternoon, everyone. Am I audible properly, right? Great. So, I'll start my video. Yeah. So just to clarify, is my actually usual ways I'll mix Hindi with English. So is it okay, or I should deliver it in English only? You can put it in chat if you want. If you want me to deliver it in English only, that's also fine. Sure. I'll share my. Is it visible? Ashish, you
Yeah,
can.
yes, it is. Yeah, it is visible.
Great, great. Yeah, I'll just. So the topic for today is backend development and microservices. We're going through the foundations and best practices for the development. Okay. But I'll brief you about myself. I'm Chintan Atia. I'm basically from Gujarat and working in Tata Consultancy Services, Pune. And I've been in this IT industry for last 19 years, out of which my 15 years have been with TCS. I've shared my LinkedIn, so if you want, you can note it down. Uh, so I have some queries, questions, or something. Can Ashish ji, it's right, or they can use the mic also.
Yeah, instead of using mic, whatever their queries, they just put on the chat.
Sure, no problem. That's great. So yeah, So the topic for today is backend development and microservices. Let's go further. Yeah. So I'll brief you about the session. What is the agenda today? So first we'll go through the backend development fundamentals, where we'll introduce the core concept of backend development and how it is different from front end. Like when there are two different words, it means something, right? So what it means and what is backend and all we'll go through. Then we'll move towards microservices, where we'll explore what is microservice, the design principle, when to use what not to use, what to take care about, and all those things, right? And then there are different architecture styles, which we'll go through, like monolith, modular monolith, and microservice, which are styles, which will we go through. And then we'll go through the best practices for both the backend development as well as microservices. And I'll share some resources with you. Fine. So let's move ahead. So first is like backend versus front end. Uh, can someone put in the chat what they understand by backend, what they understand by front end? I'll try to, if you don't mind. So can someone backend what is front end? Anyone? Okay, I'll move further. So it's basically a visual representation of data. It can be anything like a web page where we put it in HTML, CSS, JavaScript, or a mobile app where we show it in a Android development or something Android or iOS development or something like that. Or it can be a report also. All right. So that is. Now we'll go towards backend develop. Yeah, Siddish. Yeah, front end shows UI of the segment, backend is development. Exactly, exactly. So front end is just the face of website, but backend comprises of data, input, output, records, etc. Perfect. Perfect. That is what a front end is. Front end is just a visual representation of data. How we want to show, what we want to show, it all depends on front end. The data can have 100 fields. If you want to show 5 fields in a tabular format, something in a different way, it is all. So that is what front end is. A front end can be anything. Logic, the storage, the data processing, everything remains in the backend. Right. So that is how we differentiate front end and back end. We'll go with like how earlier front end and development were managed later when we go through different architecture styles. But when the topic is backend development, so what is backend that we first need to know. So this is what differentiate between backend and front end. One, it is just a representation of data. Second, it processes the data, stores the data, does all the validations and all the things, the full business logic. Basically, you can say backend is the brain of the application, right? Now, front end and back end. In the modern applications, front end and back end communicate via APIs. Okay, APIs, application programming interface. So basically, it's interface between two different applications. That is called an API. So a front end sends a request to the back end processes it, identifies the data that needs to be shared back to the front end. It sends back, front end captures back the data, processes it in terms of what needs to be shown and how it needs to be shown, and shows it to the user. So that is how front end and back end works. Okay. Now, see, my expertise is with Java, so I'll mainly talk about Java frameworks, where Spring Boot and Hibernate are mainly two popular frameworks used for backend functionalities. Anyone has heard of that, or anyone has used that? I guess you all might be using it in your projects and all, right? So Spring Boot is basically Java framework where it helps us is faster because it has many things inbuilt which reduces the code that we need to write. ORM framework. ORM is object relational mapping, where it helps us in communicating and storing and the data in the database, and it makes our life easier as a developer. Flask the query is okay. Flask. I'm not sure. I've not used it before, but I'll check and get back. Sure. Okay, I'll move further. So yeah, this is how a user interacts with their application. User communicates with the front end, where front end is, let's say, made up of HTML, CSS, and JS, while the back end is our, as I said, the brain of the application with the business logic. It communicates with the database, processes the data, and gives it back to the front end where the user can see it. Clear? Now let's go towards the role of backend in the application. Backend handles the server side logic. The backend resides on a server. The server can be, sorry, a Tomcat server or a WebLogic or any kind of server where we deploy our application and the processing. It can have interaction with other backend applications also. So it basically anything that relates to the processing of the application, processing of the data, and storing it and all those things, that is handled at backend. It doesn't handle anything related to how data is visible to anyone. All it understands is the form of data, it processes it and gives it back. Fine. The core technologies that are database, the APIs, and the frameworks of the APIs, where the framework actually helps us in handling our APIs better. It helps us in or a better and faster delivery of whatever our system helps us do function it smoothly. Yeah. So there are many applications of backend where everyone must be using e-commerce apps like Amazon or Flipkart and everything, right? So that all these applications are working on APIs. Let's take example of Amazon. Uh, Amazon, we all have like Amazon app on our mobile, right? Now, let's say you put something in your cart, okay? Now, somewhere your mobile get discharged or something, and you want to access it on your laptop or desktop. You log in into your Amazon site, you still see the same thing there, right? So again, the representation of the data is different, but the data is same. The arrangement of the data on screen is different, but still you see the same data there, right? So the API that the Amazon site calls to get the data, get the items in the cart is the same API that the site calls. It is the same API that the So we get the same output, but it is represented in a different way. Similarly, the banking apps. There are net banking applications available, and similarly, mobile banking applications are available for us to use. It again shows the same data, it again does the same transaction, but in a different way. The visual representation is different, and the processing is the same. You still get the same. Don't have enough money in your account, you can't transfer the money. All these things are handled in the same way, but the UI is different. So it all works on the APIs, where the front end, there are multiple front ends available, the back end is the same. Similarly for social media, where we use Facebook on the website as well as the mobile application, and we again see the same data in a different way. So that is how the backend helps in keeping the business logic same while the presentation is different. Right? And again, the user authentication is a mandatory thing. For banking apps, you should not be able to see anyone else's data, and no one should be able to see your data. So that's why your authentication is required. Data. So all these things are managed by the backend application. Right? And with the increasing use of mobile applications, the usage of mobile application enables us to get the things faster, and that makes us less patient in like I've seen, I'm with an Indian bank, and I've actually seen where the used to say the system is not working. We used to be patient earlier, that okay, we can do it tomorrow, but now it is not the case, right? The thing immediately comes on Twitter or somewhere, or rather X now, yeah, that the bank application is faulty and all those things. So as a developer, it is our responsibility to make it reliable, secure, scalable, and a performance enhanced application, which is a mandatory thing now, or else with the increasing use and the increasing uses, I'll say it is increasing not in a serial way but in a logarithmic way. So we definitely need to make our applications more scalable and reliable, with definitely secure is the key. These key definitely need to be taken care while we develop our applications. Okay? So we need to consider while developing our APIs. Yeah. APIs nowadays are REST APIs, right? Anyone has heard of it? What is REST API? What is REST? What is stateless? Can anyone say? All right. So yeah. So see, REST APIs are basically a form of communication where we communicate between the applications through HTTP protocol, and all these APIs are independent of each other, right? So the second API call is nowhere related to the first one. There is no communication, or rather storage of state between them, and that's why let's say a request comes to me for uh, uh, something where uh, let's say again, let's talk about e-commerce application where I'm fetching the data for uh, let's say I want to buy a mobile, right? So I'm getting the data for what all mobiles are available at what prices. Next request I send for I want to buy a tablet. So I do. There is no connection or no state saved between them. Yes, one possibility might be it might check whether the user is logged in or not, but the link between two APIs is not there. Okay, so that is why it is a stateless communication. Fine. Now, another thing that we need to take care is we need to use a standard data format. Mostly it is a JSON, which is the most widely used data format. But another one is XML, where we have data in the XML tags. But while development, it is necessary for a developer to have a proper validation of input data so that there is no junk data available, there is no malicious data available, which is an essential thing that every developer needs to take care. If we don't have proper validations, then the API, the application becomes unstable, and we have seen, like in my personal experience with that, where the without proper validation, it can create a havoc, right? So we actually need to have all the validation, and if it is the I will say the backend, while some validations can be handled at front end, it is necessary to have it at backend so that from any input, from anywhere it is coming, at least the inside application has proper data available. Otherwise, the data quality issues and a number of things that can happen. Fine. So it is a necessary thing for uh, an API is to have a proper input validations. Then there are security measures that we need to take care. So I see two words here: authentication and authorization. Can say the meaning of that too. I know it is not exactly related to the topic, but still it is linked somewhere. Anyone knows the meaning? Hello, audible?
Yes, you are audible.
Yeah, yeah. So, and anyone can. So it will be great if we make it interactive so that everyone gets to participate, right? Fine, let's move ahead. So, authentication is right. Rishil, yeah, great. Authentication verify user perfect. And authorization, anyone? Let's say uh, let's talk about still you only. You might be having some portal of your college, right? Exactly. Auth- Authorization is all about giving allowance, right? So let's say I'm in TCS. So we all have a like company where we can log in and do our filling up timesheets or apply leave or something, right? Now, if I log in, can I do all the thing that the CEO of the company can do? Should I get access to all the data that the company CEO has? The answer is no. In exactly. So we cannot have that access. So even if I have access to my company's portal, I cannot have access to all the data available there. I cannot have access to like salary data of any other employee of the company. I should have access to only my data. Similarly, for bank application, I am allowed to log in as a customer, but I cannot see anyone else's data. I cannot see anyone else's account or balance. I'm not allowed to do transaction from that person's account, right? So that is what authorization is. If I log in, I am able to log in, that is authentication. But what access I have, what am I able to see, what I'm able to do, that is what authorization is. So both the things are equally important. Just excuse me. Yeah, right. And there are tools like JWT or OAuth, which helps an API to have uh, the security measures. Have seen somewhere sign right. So it uses JWT. JWT is JSON web, which has like without that password access, you have a web token which is encrypted and has the proper internal validations to handle that authentication. Fine. As we talked earlier, performance is one of the key things, a necessary thing that we need to handle during the backend development, because as the application, the organization grows, load will be coming, and the more we handle the performance better, the better it will be, right? And monitoring of the application where let's say again, if say I'm working with a banking environment for last 15 years, so my many examples are related to banking. So let's say if I'm not having a proper monitoring in my application, if application, if it goes down or some APIs are not working there, right? So ultimately the customer suffers, right? If the customer suffers, ultimately it's the organization's reputation that takes a loss, and ultimately it leads to dissatisfaction of the customer and the loss of the customer, where and ultimately finally it leads to the like reputation loss of the organization, as well as the I'll say business loss for the organization. So that is what a lack of a proper monitoring, proper performance leads to, which no organization wants, right? So that's why it is necessary to have a proper performance handling, monitoring, post go live, and all that is one of the key things which we need to take care even before we put the application into production, so that there are no mishaps there. Fine. Any queries so far? Or will go for the queries in the end only? Fine, let's move ahead. So, see, we have the frameworks related to REST API development in Java, where majorly Spring Boot is used, which is a very efficient and a very concise framework where it is very easy to develop a REST API quickly. Within a short period of time, we can have a small application made and go live. That's and mainly it works on annotations, which actually helps the developer to understand the code as well as develop the code very quickly, right? Then we have the request response format in JSON. uh, JSON is basically a plain text data which can easily be read by any application or any language, programming language, including JavaScript. So it is very easy for communication, as the JSON can be easily converted to object by Java or .NET or any web application framework also. Fine. Then let's say there are some changes that are required in our application, or let's say some more fields are required to be added. Right now, an API can be used by multiple applications or multiple uh, client or customer, right? And it is not possible for all of them. Like I'll say about my environment here, where I have APIs that are actually used by 15 different vendors. And let's say a field requires to be added there. Now I develop it, and for all the 15 vendors to go live at the same time, right? It's practically impossible. So it is a mandatory thing that extend our API features in a very a safe way, where it is kind of backward compatible. We need to have a proper or validations and exception handling. We need to have proper API versionings also, which helps handling these type of scenarios in an efficient way, where some vendor or some customer or some client can have older version of API, since it doesn't require to be gone to new version, or if it is a gradual movement, it can be handled in a good way, right? It can be handled in a safe and secure way. So that's why extending API features needs to be handled in a proper with due care, where nothing fails, right? Now let's go towards see anything you want to ask related to backend development, because we'll go towards microservice. Because backend development is the key for going towards microservice. All the microservice are mainly related to the backend development. So anything you want to ask? Fine, let's move ahead. So yeah, just lightweight. All right, I'll just ask. Anyone has heard of what a microservice is? Can anyone say anything about it? Anything you know about it. Okay, great. It's big application is broken into small independent services. Yes. Anything else? Does it change how we develop things? Okay. Can you tell me how? Okay. Right. So I'll say you guys are way ahead of me when I started knowing about microservice, because I'll my query to Google about microservice was how many APIs can be there in a microservice. Because first time when I heard microservice, I thought one API per microservice. That was my understanding at first, but then I read, developed, understood, and I got how wrong I was. But yeah, there is no harm in being wrong there. Uh, we learn. So yeah, let's go to the introduction of microservice. It's basically an architecture pattern. It's a way of development. It's a way of deployment. It's a way of maintenance. Uh, mm, and it is not about what we develop. It's not a language. It's not a uh, I'll say it's not a new type of API that we develop. The API development is the same, but it is about how the development is managed. It's about how the application once developed it is managed. So that is how microservice is different in the way the older applications were handled. So as Suhana said correctly, it's the applications are divided into small independent service. Here the word independent is very important. If the services are not independent, the architecture is a complete failure. Okay, so uh, it's like again, let's take example of e-commerce website where we will have a login service. Okay, now login has nothing to do with payment, right? Login has nothing to do with displaying a catalog, right? You can actually have a catalog even without logging into the application, an e-commerce website, right? So all these things are independent of each other as long as they are maintained properly. Okay, so architecture has to be defined in a way where we identify what all things are independent of each other, what all things are dependent on each other, and accordingly we need together, we need to split them away so that each can be handled in a way where one service doesn't break the other, even though it is required to have some dependency. Like again, if we talk about e-commerce, it is necessary to validate that the person is logged in when we go for a payment, right? So At that time, while the login service can be different, there can be communication between different services through different APIs to handle different business capabilities. So a microservice architecture is purely based on how a business capability is handled, how they are independent and dependent on each other. Fine. So that is with application into different microservices, where one microservice and number of APIs, which I got to know later, as I said. But yeah, those APIs need to be related to each other. They need to be like part of the same business functionality, business capability, so that they can be handled in an efficient way. Fine. Now, uh, it has multiple advantages over how the earlier development used to be handled in a monolithic way. Okay, we'll get to know about monolithic and other architecture pattern later. But yeah, monolithic is an application where everything is together, right? It's a big application where all the things are handled together. Okay, and microservices basically uh, business capabilities were splitting a monolithic into small services that can be handled independently. So now, since it works on a smaller scale, it offers more flexibility. Since there is less dependency on each other, it is faster to develop, it is faster to deploy, and since they are independent, uh, it helps us, like if we change one, if we, let's say, have some additional functionality developed in one microservice, it actually doesn't affect any other. So the testing is less, it is more resilient in a way it is handled. There is no need to worry about any other service that can get broken due to this change. While in a monolithic, when we have let's say 1000 or 15,000 files deployed in a single application, okay, if one thing changes, it can break everything. Let's say there is some issue in one file where we miss something, or this the whole application, the whole functionality can fail. We need to work on the whole application once again, and the testing effort for having a development in monolithic is far higher than anything that we do in microservice. So that is how it is better than monolithic. That is where it has advantages. Yeah, there are some disadvantages. We'll talk later. Right? Yeah, it's about challenges and complexity, where we have there are, see, it's microservice is all about distributed computing, right? Uh, a service can be a service can be deployed anywhere in the environment. It can be deployed on cloud. Multiple services can be communicating with each other, and all this communication is through network. There are different API calls. So one service can be calling other service, the other service can be calling third service, the third service can be calling the first one. So if we have a visual representation of a microservice, you can see it as a mesh of things where multiple service can be communicating with each other to handle the data. Okay, so managing communications is a key thing in a microservice. And when there are multiple applications, each microservice is an application. Okay, so when multiple applications are communicating with each other, it has to have a data consistency, which can be a real headache when the system becomes too complex, right? So when the mesh is too complex, handling it can actually become a mess. We definitely need to take care while designing a microservice. We need to handle it in a very careful way. or else we'll have very trouble in handling a microservice. So while it gives many advantages over monolithic, there'll be a very robust mechanism to handle the communication is a key feature, which is, I'll say, a prerequisite of having a microservice. Without that, if we go towards microservice development, it's it's a recipe for failure. All right. So this is how different services communicate with each other, where there is a service registry, where any service gets up, it registers with a registry. Different services communicate through API gateway, where the API gateway acts as a central thing, medium between different services, as well as any request coming from the. Fine. Shall we move ahead? So a key question, why to use microservice? Okay. Since it is small, it has definitely a scalability advantages. Like I'll say, see here we are dealing with in my we are dealing with multiple applications. Okay, some are monolith, some are modular monolith, and some are API based services. Okay, so now when it's a monolith application, there are multiple functionalities, multiple features handled by a single application, and then it requires resources. Now, let's say on some day there is load. Okay, like okay, if we talk about banking application, uh, we see a heavy load during festive season. Okay, where people are like out shopping, and then it is now, since cash is less used now, we have UPI and mobile banking, which is the backbone of the Indian financial system. So on festive season there is a huge load. During IPL days there is a huge load on UPI, which we may see a decline since the ban of the betting applications. But yeah, we see that, we actually see a huge load there. So at that time we need to be ready to handle that kind of load, or the whole system can break. Now let's say I have a monolith application handling everything. Okay, a monolith requires huge resources to handle the application. Now, uh, during festive season, the load is expected to be doubled. Okay, so I need some scaling there. Okay, one possibility, I increase the what is it, the resources on the same application and handle it. Second, I put a and balance the load between them. But at that time, I actually the same amount of resources that I gave to the first one, right? So the scaling becomes difficult, as well as uh, it becomes like uh, I need to have that type of resources available with me anytime, so that I can deploy it. And okay, now that monolith application, as I said, handles everything. Now the load of UPI has increased. Why to keep provision for a double for some other application? Why should I do that? If not required, load is not to increase on that, right? So that's why. But since it is a monolith application, I need to have it actually requires that the provision for that also is required unless the application will fail, right? So now in another scenario, I have a microservice for UPI, okay, or a microservice for let's say IMPS or mobile banking, okay. Now I know that the resources required by UPI application is far lesser than the huge monolith. Okay, so I know that the load is going to increase on UPI application. I'll just have a parallel application only for UPI, which actually requires far less resources, right? So it has a huge scalability advantage where I can scale the application with less resources and handle the increased load anytime I want. Okay, so that is one of the advantage that we have when we have microservice. Okay, another advantage, agility in development. Let's say I have, as we talked earlier, when I'm developing something, again, a new service is required in UPI. Okay. Uh, why should I test mobile banking? Why should I worry about mobile banking when the only change I am doing it is in UPI, right? But if it's monolith, I develop it, I do a unit testing of that. I need to do a proper integration testing. I need to, so the efforts for development as well increases multifold if we have a monolith application. While in a microservice, it helps in developing and delivering it faster. We have a quicker time to market when we have that agility, when we know that okay, there is no impact on something else when I work on something else, right? So that is how it helps in faster releases. And since as we talk about definition of microservice, each microservice handles a different business capability. Okay, each team can work in a different way. Like UPI microservice doesn't work on something else. They can work independently, they can work in a faster way, and they can deliver it faster. Let's say something fails, something went wrong. Okay, we have something called fault isolation. What has failed, we can easily isolate it, we can easily identify what went wrong. See, let's say again, if we talk about the same UPI example, mobile banking example, I have done some changes in UPI. Okay, I can easily contain it in a way where, okay, what has changed last? This cannot impact this thing, I easily know. Okay, so that is how it helps in faster resolution of issues. When we have smaller services, the smaller thing is always easier to handle. Okay, then we have uh, DevOps and orchestration, which is again a key thing if we are working with microservice, because if we have multiple services running, it becomes practical and humanly impossible to handle it manually. Okay, it's practically impossible. Let's say I have 100 different services running. Okay, a person sitting there cannot deploy, cannot monitor, cannot handle everything on his own. Okay, so it is necessary to have a proper DevOps setup, a proper orchestration where the load handling and all those things are handled. Without that, again, it is a recipe for failure. It is bound to fail. A microservice architecture is bound a proper DevOps and orchestration setup. Okay, setup available. It's very easy. We can handle it in a way more efficient and automated way than we handle a monolith. Okay, and there are tools available in the market like Docker, helps us in managing this in a very practical. Okay, all it has is some scripts, a proper setup, and we are good to go. Right? Different architectures comparison. Okay, we talk about a monolith. It's a single unit. All components like UI, business logic, and data are packaged in a single application. Okay, so from the first slide we talk about how front end is different than back end. Okay, what front end does, what back end does. Now in a monolith, both are clubbed together. We have MVC pattern to handle monolith architecture, but still everything is clubbed together. It is a very uh, it has its own advantages definitely, but still it is hard to scale and maintain when the system is very large. As I said, the major efforts required to maintain as well as develop, test and maintain those applications with a huge chunk of resources required. Plus, as the UI and business logic and everything is clubbed together in a single application, there is thin boundary between that two, and there's a huge dependency when some uh, the front end, it requires change in the back end, which is not the case when we are working with APIs, right? So a monolith architecture, while it has its own benefit, it has its own negative side as well. Now, there were the years back, the monolith was the only architecture available. After that, the developers, the architects matured and came modular monolith, or in short, modulith. Okay, it has an application. It is an application which is modules. Okay, while it's a single application, everything is clubbed together into a single var or ER file. Okay, a single var, ER, jar, whatever you call, everything is clubbed, but internally it is handling in different modules. Okay, so where it helps, again, if I change something in one module, it doesn't impact the other module. So the testing efforts reduces. It gives a good amount of fault isolation, where what has failed, based on that we can identify what has gone wrong. So it helps in a better maintainability, right? Uh, but the deployment of that application is still in a single go. Okay, so it still has the disadvantage, one disadvantage of monolith, where the resources required are high. The only the benefit that it gives is it gives a better maintainability than monolith. So it is like a intermediate layer between monolith and microservice. Okay. The next one is microservice architecture, where our the topic of today is focused about. Uh, to talk, it is a architecture where an application is split into small independent services. Each service will have its own database so that it can work independently without any dependency on the other application. Okay, and all these services communicate through APIs rather than any direct communication, other direct communication. Okay, since it is small, again, it helps in a better scalability and autonomy. Autonomy in terms of development, where one team is not dependent on the other team to develop. Okay, it always has an API contract available with them. if that contact is available, both, even if there is dependency between two different teams where a development of one team is pending, like both the teams are going parallel, if they have contact available, both the development also can go parallelly. It gives a greater amount of autonomy. But yes, there is a complexity available. As I said, it's a mesh kind of thing. If we don't maintain it well, it can go wrong. Okay. So let's talk about, let's have a summary of all the three architecture patterns, where again, a monolith is a single unit, modular monolith is single unit with different module inside, and a microservice is a multiple independent unit. The scalability is limited in monolith. It has some benefits in monolith, but still it has some limitations. The scalability is very high in microservice. Complexity, if you see here, the complexity is very high in microservice because different services communicate with each other. Which services communicates when, where, how, where it goes, it is all dynamic. Okay, so we need to be very careful about when we develop, when we maintain the traceability of a request needs to be handled very carefully, and that's why while it is easier to develop and deploy, microservice its own complexity have a maintainability and observability. Okay, and it but while every team is working in a different way, it has a better team autonomy. Again, one more benefit that we have with respect to microservices, it can have every different microservice can be having a different technical architecture, a different technology stack. It is all allowed, it is all possible, and very easy to handle, since all communication is through APIs in a standard format like JSON or XML, which is purely text-based communication method. Okay, so now when to choose which architecture, when to choose monolithic? Can anyone say when we should have a monolithic architecture? Any idea?
Sir, when we have a small scale application.
Okay, good.
When the transaction is also considered.
Okay. But in that case, what about financial app where the transaction is the main thing that we need to handle?
We can just like the database can be stored in Docker by using RabbitMQ.
Good. Okay. So even a financial app can have a microservice architecture.
Yes,
We
it
have,
can have.
yes, because see, even we have distribution transactions also available, right? So transaction can be used with respect to financial transaction when we have multiple services handling that. So while it is required to be done in single transaction, monolith is while good, but if it gets too complex, we should try to avoid it. So yes, as someone said, it is best for small applications which has not a too much complex thing. We should ideally go for monolithic, since even monolithic has its own benefits and advantages. Okay. Next is modular monolith. Is it's suitable for medium. It has some benefits of monolith, some benefits. Okay, so it's an intermediate thing, and it's required, or it is ideal for large scale application that requires independent scalability and a distributed team collaboration. Now, I read it somewhere, like an architecture of the application is heavily dependent on how your team is organized. If I have my teams structured in different modules way, it usually is a modular monolith that we develop. Okay. If my team is structured in a way where my business capability is handled by a team, my prefer or rather microservice architecture is by default adopted by the team or the organization. So it is heavily dependent on how your team is organized, and that is why you must be seeing somewhere a full stack developer is required, right? Or now we have teams where one person is handling front end, one person is handling back end, one person is handling database. So it is all clubbed in a team, right? So we have a cross. Earlier, what it used to be like a front end team, what you say, one team used to handle only Java part or something like that was there, which gradually changed with the way we developed the things, and it helped a microservice architecture, a monolith architecture to evolve as we went further. Okay. Now, what should we consider when we adopt an architecture? Like, it's basically a what microservice is a kind of buzzword. Okay, everyone wants to go for microservice, right? But when it is not required, because it has its own complexities. If we do it when it is not, do it uh, before it is required, or if the team doesn't have the capability to handle it, it's definitely bound to fail, right? So see, if you don't have the right tools to maintain it, it is very difficult architecture once it goes live. Okay. So we and so quote is down there: monoliths are simple until they are not. Microservices are complex from day one. Yes, that is a true statement. Microservices are a very complex thing to handle if we don't maintain it well. Okay, so let's say we have like 100 microservices communicating with each other to handle a functionality. A request is received from a client. What is the flow of the application? Let's say it failed somewhere. Where did it fail? At what stage it failed? What do we need to check? There should be a traceability, and if we don't handle that, we'll never be able to trace a request. We'll never be able to, right? So we need to be very careful when we adopt for microservice architecture. We should not do when we are not ready. Otherwise, it is very difficult to come out of any failure. So do not go behind the buzzword and the rat race of implementing a microservice. Otherwise, it's a very difficult thing to handle. Okay, so let's so it's the image shows when microservices go wrong, what happens. So we'll go for the advantages, disadvantages for that. What are the advantages? We already talked about these things: independent service scaling. If I require a UPS service to be scaled, I won't focus on anything else. I can handle the service scaling independently and handle the dynamic or random load that is required. Yeah, see, I guess we must have, I think there was some session related to cloud computing as well, right? Where the cloud can be helpful in scaling and all. So all these things are interrelated, where a be deployed on cloud, and it can be scaled independently. The smaller the service, the better the cloud will be able to handle it. Okay, so all these things, the distributed computing, cloud computing, microservices, all these things are in a way related, and should be a person who these things should be having all these kind of stuff to have a better visibility, better understanding of the architecture as well as the services. Okay. Another thing that we talked about was fault isolation, which that's a benefit of microservice, where uh, we can isolate a fault, we can handle it in a quicker way, and avoid cascading failures, which helps us in overall system failure. If my again a UPS service is failing, it doesn't impact on anything else. Okay, that is how it is helpful. Again, we talked about this. It gives us a benefit of having a technological. Each microservice can be different, can be developed in different and still it can be handled and work efficiently. It all depends on what is our need and how we can handle it. Fine. Then it requires uh, a robust infrastructure, but still it can have uh, a smaller infrastructure when it comes to uh, the maintenance. Since if at times when we require only scaling of one microservice, we don't need a huge infrastructure for that. But it requires a proper and disciplined development practices. Otherwise, the benefit that it gives related to infrastructure is totally gone. Okay. Now let's talk about the disadvantages. Okay. Microservice is complex. But, as I said, it's a mesh when multiple services are communicating with each other, and identifying a source of failure when there are multiple communication is difficult. A traceability, which request failed, when it failed, why it failed, becomes difficult. Okay. Now, as I said, each microservice is a different application. If I have 100 microservice, I need to maintain 100 applications. I need to constantly monitor them and handle failures. If it is one application, it's very easy. I can make one person sit there, भाई ये देखते रहो, right? Or I can have an automated mechanism where it tells me about any failures in one application. But uh, when I have multiple application, I need to constantly monitor, I need to correlate between them. When something goes wrong, it actually is, and the more the application, it is difficult, and it increases the complexity, and uh, any network failure also can lead to a complete failure in the microservice architecture. Okay. Okay, network latency challenge, there is slowness in the network. It actually impacts the whole performance of the all the systems available. Okay, data consistency issues. Each microservice is having its own database. That is how it should be developed. Otherwise, there is no point in developing a microservice. It's one of the key features or a key requirement of a microservice. Okay, so and when we have different database available, it is very critical to have a data consistency across all the databases, which can become difficult if we don't handle it well. Okay, so it is one of the key things that we require. Now, why do you think microservices should have its own database? Any thoughts? Anyone?
So because that will help to scale a particular macro service.
Okay, good. That is one of the reason. Any other? You all must be using some banking app, right? Or UPI. Okay. Anytime have you seen a message like from 1 to 3 at night, UPI services will not be available,
Yes, sir. Yes, sir.
right?
That is for
It comes for
maintenance.
it is required for maintenance purposes,
Yes, sir.
right? Every application requires maintenance. Now, let's say all I have microservice architecture available with me, but everyone connects to the same database. I need upgrade of a database. Let's say I'm using Oracle 19c. Now I want to upgrade to Oracle 21 or 23 or whatever is the latest version. Okay. Now everyone is using the same database. Okay. I need a complete downtime of all the applications connecting to that database. Right. To avoid those kind of things, if we require an isolation where all the services need to work independently, I cannot have a single source of failure or a single dependency handle that. And that is why it is ideal. Again, I'm saying ideal because some sessions are required depending on the nature of the application. Okay, but still it is ideal to have a independent database for every microservice. Okay, now let's go further. That's common pitfalls. Over engineering. We tend to think a lot. We tend to go for an ideal answer, and we don't move further till we don't get an ideal answer. Okay, and it ends up having a smaller than required microservice. Okay, where and as I talked about my initial understanding earlier, one microservice, one API. Okay, that is an over engineering and overkill. So the more we try to dissect it, the more complex it becomes. Okay, another thing, poor observability. Observability is very closer to the monitoring that we. The more complex an architecture is, the better monitoring and observability mechanism it requires. Okay, if it is poor, we are bound to fail. Will not be able to trace any failures, and ultimately the whole system will break down. Okay, so these type of pitfalls we should avoid. If we are not ready with that, we should not go microservice architect. Okay, so yeah, funnier definition of microservice, it's turning one big headache to a distributed migraine, but we can scale it, right? So now let's if before we go for best practices, any questions you have?
So for our demo round, should we use uh, monolithic or microservice architecture?
See, it all depends. Okay, see, one thing personally, I'll not be able to show you a demo since I don't have a lab set up here, okay, on my machine. But yeah, for your demo, it all depends on what your demo is about. One, if it's a demo for microservice, you should not go for monolith. One, okay, so one I'll not. But while microservice is a current trend, you can definitely show it, but as we talk about the pitfall, okay, you should not over engineer it and make it very minuscule. Okay, so actually it depends upon what your question is, what your demo is all about. If it is not required to be go for an API based development, if it is not required to go for a microservice, don't try it. Okay, about the demo, it's like it's a one day thing, or how it is, like I'm not sure.
Yes, sir. It is 2 day thing. I think 26
Two
hours.
day 2 day project to develop. Okay, so there'll be a question given to you, and you need to develop some application on that problem.
Yes, sir.
Okay. So like, see, if it requires something based on API, think about a microservice architecture. If you can develop it, good. Okay. But as I said, don't try to over engineer it.
Okay, sir.
Right. If it is API based, think about microservice, because it will help you think it in a cleaner way. Try to
Yes.
isolate different like independent things and develop it differently, so that if you have a team of developers working, each one can work on a different service. Your development will be faster. Fine. Okay. So shall we move further?
Yes, sir. Yes.
Yeah. Okay. So see, there are always some best practices when we go for a development. So for backend API development, we should use different HTTP error codes. And I guess you must be aware about different error codes, like 400 is like internal error, and 500 is internal error. 404 is a page not available, or the service not available. All those HTTP error code should be used properly, because it's a way of communication. Someone on the other side can identify the problem immediately with the help of an error code. Right? So we should use proper HTTP status code and error code. Right? Then security is one of the key features that we have. So we should always secure our endpoint. We should use proper authorization mechanism, as well as encryption mechanism to handle the secure our APIs. Fine. Then as we talk, API versioning is one of the critical thing when we want to handle backward compatibility. Okay, so that there is no disruption in someone who is using an older API. Okay, and we should always have a comprehensive documentation when we are developing API. There is a tool called Swagger, if you have heard of it. Okay, it helps you in documenting the API properly. It actually gives an online or like a visual representation of an API, and it can also help you develop code. So there's a tool that you can use. Okay. Then best practices for microservices. You should always use service discovery and configuration when we are going for a big scale microservices. It helps in if some service goes down, the service discovery can help us identify the fault and have a central repository of all the services available. Then we should always go for some resilience pattern. Like I've given example of circuit breaker. Circuit breaker is something like let's say one service is starting to give some failures. Let's say some load is increased over there, it is not able to handle that. Okay, it helps us handle those failures gracefully. It can distribute the load, or breaks the circuit over there, so that there is no cascading failure. Okay, so those type of things can be handled by different microservice patterns available to handle the failures. Okay. Then we talked multiple times about that. It's a critical thing to have in a microservice architecture, where we need to have a thorough monitoring. There are tools available which gives you a visual representation of and traceability of all the requests coming in, and it helps us in monitoring the application in a better way. Okay, and the loose coupling is required between microservice. Otherwise, if multiple services are too much dependent on each other, then again they are not independent, and there should not be different microservices. Okay, and there is too much communication between multiple services, then there's always a network coming in between, and there is always a lag. Any network failure can break up the whole architecture. So we should always be careful about that. We should always go for these type of things where we should network communication to enhance the performance. Okay, now let's talk about some tools which are available in the market. Development, Spring Boot, we already talked about this for Java based development. Then Postman is used for API testing. So when we develop an API to test it, Postman is one tool that we can use. Then for containers and orchestration, Docker and Kubernetes are there, which helps us in scaling the microservice in a better way. Then you can note down some learning resources which I have found. Those are available. There's some books, courses, tutorials on YouTube and all, which you can refer to learn more about the backend development as well as microservices. Okay. So shall we go for some question answers? If I can. Very simple questions related to today's topic, nothing else. Can anyone answer this? Okay. Perfect. It's database. Next one. Very simple one. That's false. Front end doesn't handle business logic. Great. Next one. Can anyone say what is idempotent? A new word has come up. Yeah. So it's a property where even if we send multiple requests, it will give the same output if we execute it once. Okay. So based on this, what is the answer of this question? Okay, patch, get. Okay, post. Okay. The answer is get. Get is basically used for fetching the data. It is a read-only method. Okay. So say give me the okay, e-commerce website, give me the price of this product. Get me the price of this product. Okay, it gives you like these many rupees. Okay. Next time if I give a same request, It still gives me the same output. Unless there is an algorithm in the backend where if you do it multiple times and increases the price, which is a high possibility. But yeah, it still gives you the similar output. Just a minute. Yeah. Yeah. Okay. So next question. Okay. Anyone else? Single deployment is in case of monolith or modulith, not in microservice. If there are multiple microservices, the deployment is not single. So, but yeah, each microservice can be scaled independently. So there is one big advantage where we only scale something with not anything else. That is where we have an advantage. Next one. I guess you already got this answer in the earlier question. Correct? False. It is false. Questions. Exactly. The answer is postman. Next one. We'll go quicker. Great. It is network latency. B. Great. It is true. Yeah, sometimes there is XML data exchange is there, but most of the times it is JSON due to simplicity of it. Correct? It is Spring Boot. Last one. Exactly. Okay, so that brings us to the end of the session. Any queries, questions you have? I hope the session was informative and we all got to learn something. Yeah, and meanwhile, someone had asked about Flask, so I googled it. So it's a web development framework developed in Python. It's a micro framework, so it doesn't require any tools. So I just googled it. I'll be very frank, I didn't know about that, and I'm mainly more into the APIs and backend developments. I'm not much familiar with the web development frameworks, but it's mainly Python web development framework, which I could just Google. Any queries, questions, or we can wrap it up? Sorry, I'm not aware about the results and all because I'm mainly here for the session only. But Ashiji, can you help with this question?
In which
It's a question in chat that when the waitlisted teams will receive the results.
okay, I am replying in the chat.
Sure, no problem. Because I'll not be able to answer that since I'm here for the session only. So if
So
there
I
are no
think
further if there are
uh,
no further questions, I guess we can wrap it up.
yeah.
Yeah, sure.
So
Thank
thank
you,
you everyone
everyone. Yeah,
for your
and
active participation, and a special thank to our trainer Shri Chintan Adiaji for sharing valuable knowledge and guidance and made this session wonderful. We wish
thank you.
all
Thank you.
SIS 2025 participants the very best for your journey and innovations. Stay motivated, stay creative, and keep innovating for India. We are closing the session now. Have a great day ahead.
Yeah, all the
Thank you,
best,
sir.
everyone. And if you can have any queries or questions offline, or if you want to connect, my LinkedIn was already shared. You can connect to me there. Thank you very much.